All right, so my name is Vera Mays. I'm one of the math specialists in the Learning Commons. But in addition to that, I always teach this class pretty much every semester. Like this semester, I have 2 sections of this class, and I've been teaching it for quite a while. So I do like teaching this one. I really like the fact that you guys get to build your base and get ready for wherever you're going next. So I have a PowerPoint that we're going to be working through, and I just went through and verified it against the test. If you're, I don't know, some of you will be taking pencil paper tests, some of you will be taking tests through Lumen where you do your homework. So I looked at the Lumen test. There were 30 questions, and I made sure that everything that's on the PowerPoint is on the Lumen, but there was one question that didn't show up, so I want to talk about that at the very end. It's kind of a review from test 1. So any questions before we get started? Can everybody hear me okay? All right. Okay. So please, if you have questions or you want to know something, or you want me to repeat it or do it a different way, please don't hesitate to ask. This is not me just lecturing at you. This is you also able to ask questions, or where did that come from? Or can you do another one of those kind of things? So feel free. All right, so this is where we're going to get started. Now, I didn't organize these in any order because the test is usually mixed up. So I thought it might be good for us to kind of go through in random order, and that way we can kind of review as we do the same type, because we will have several of the same type as you go through the test. All right, so the first one, come on, let's see if I can make sure my little tablet's working here. Come on. Annotate, let's get a pen. All right, so the first one, it says, write the inequality using interval notation. So that means interval notation, you tell me where it starts, you tell me where it stops, and it is important whether you put a bracket or a parenthesis on these. So one of the ways I like to do this is I like to think about what's my important number. Well, my important number, and of course my tablet's not working, so it's harder to write on here. So, oh, here we go. Okay, 3 is my important number. Okay, there is no equal bar underneath this sign here. So for now, I'm going to put an open circle, not a closed circle. And this says X is all the numbers less than 3. So less than, I hear the L telling me go to the left. And it does help if I kind of go ahead and put the 2 endpoints on the number line, negative infinity on one end, positive infinity on the other. And so when I look at this, remember interval notation is always left to right. So on the left-hand side of what we shaded here, I see negative infinity. And on the right-hand side, I see a 3. So that means I can already eliminate 2 of these. I got a 50-50 chance now. So infinities, what do infinities always get? Do they get a bracket or a parenthesis?
Parentheses.
Perfect. So, okay, we still got 2 answers that look good. Now we had an open circle. So open circles, do they get a bracket or a parenthesis?
Parenthesis.
Perfect. So there we go. If this had been a closed circle, I would have chosen the bracket. But this is why I think putting it on a number line and getting a quick little picture, you can see the beginning and you can see the ending of this. And there's no questions about which part to put in your interval. All right, any questions? All right. You guys, as we go through, if you want to give me a thumbs up or just let me know. You know, I can't see some of you because you don't have your pictures up, so you can't just shake your head for me. Let me know. All right, so the next one is a little bit of a word problem. So as we look at this, we need to think about what are some of the important words we know. So I'm going to go through and try to figure out what words mean something that I need to translate from English to math. So what does the word quotient mean? Any idea?
Divide.
Very good. So there's division going to be in this. A number. Okay, well, let's call it X. So the quotient of a number and 8. So that means I'm looking at a fraction of a number divided by 8. So let's look at these and see which ones have a number divided by 8. A number divided by 8. Here's the number divided by X. So I'm going to eliminate that. Okay, here's equals. So we know that's our equal sign. 4 more than the number. Well, we called the number X. What is more than? What symbol could I replace that with?
Addition.
Very good. So I'm looking for 4 plus X. So X divided by 8 is equal to 4 added to X, or X added to 4. The order doesn't matter. So it looks like there's my final answer, because this one would have been times, or the product would have been another word. This one would have been difference or less than instead of the more than. Any questions on number 2? Okay, go ahead and go to the next slide then. All right, so now we're solving an equation. And I don't know how if you guys have talked about like good old Aunt Sally or Jim or something, but we got to get rid of these parentheses before we can really do anything else, because they hide things. So let's go ahead and distribute. So this is not going to change this side. 9 times X plus 9 times 1, and then bring down the 4X. And now when I look at the right-hand side, I see that there are terms that are very similar. So let's go ahead and combine the similar terms. So let's not deal with the left-hand side yet. 9X minus 4X gives me a 5X. So I combine those two, and then I can bring down the 9. Okay, so now what I'm left with is 5X plus 9 equals 5X plus 9. Well, is that true? What do you guys think? It looks, they're exactly the same, doesn't it? So this is the kind where it's always true. Oops, I spelled always wrong. Let's get rid of that. So I don't want to record that. So always true. So this would be all real numbers. Anytime you get the same thing equal to itself, you're going to choose this one. Now, this is a good time to talk about the others, especially the second option here. If I had gotten, let's say I went ahead and solved this and got my X's on one side, my numbers on the other. If I had gotten to the point where I got 2 equals to 3, is this true? Never, right? So this is when you see an answer like B, where it's an empty set. There is nothing, no time in the world where that is ever true. So that's why they're giving you 4 choices potentially on something like this. It could be just give an answer, it could be a multiple choice. So it's either an answer like you solve for X and you get a solution, or you solve it and you get down to the point where both sides are exactly the same, which means it's all real numbers, or you get something that makes no sense. And so then it would be empty set or no solution. Okay, any questions on this type of problem? Use your basic skills, get rid of the parentheses, combine like terms. Just like you're solving for X, you don't have to think about where the answer go. You're just trying to clean it up and see what you get. Okay, everybody okay?
Yes.
Okay, let's look at slide number 3 then. Okay, so this is another one where we're solving. And I noticed, even though you guys did slope on the first test, there's at least, the test that I pulled up, the version, had at least one question about slope. So it's really good to kind of, they're going to keep reminding you of it because it's not going away. So remember you dealt with good old y equals mx plus b, and then you were able to look at the line equation and say, okay, here is my slope. So this one didn't start out looking like that. So can anybody give me something that might help us get started? What could we do?
Subtract 3x from both sides.
Yeah, let's bring that 3x over because we don't want it on the same side as the y. So it cancels here. We're left with 7y. And I'm going to put the x term first since that's how the generic form kind of looks. And then put the plus 10. All right. One last step to get the y by itself. What would we do?
Divide by 7.
Very good. Divide everybody by 7. Keep it all nice and balanced. So we have negative 3 over 7x plus 10 over 7. Nobody reduces, so I'm done rewriting it. And so now I come back over here. Since it's y equals mx plus b, I know the number in front of the x is my slope. So then I just have to come over here and find the one that looks like it. So I'm looking for a negative 3/7. So I'm getting rid of these two. Negative 3/7, they both look the same, except for one time they labeled the slope and one time they called the intercept the slope. So we definitely don't want that one. This one is the right rewrite after we've manipulated it and got the y by itself, and the number in front of the x is our slope. So even though you haven't done it for a little bit, it's going to be there. So any questions on this one? All right, sounds like you guys are doing pretty well with this so far. So let's keep going and see if there's something that comes up that doesn't make as much sense. All right, so in this unit, you really played with math words and converting them from English to math. So you had to understand some of the basic operations and some of the basic translation words. So sum, what is the word sum telling us to do?
Multiply.
That's product.
Add.
Very good. Product is multiply. Sum, so we're adding things. How many? We're adding 3 things. So this is where it gets interesting. Consecutive even integers. So if we're just talking consecutive, that would be like 1, 2, 3, right? They're right in a row, right next to each other. Can somebody give me an example of consecutive even integers?
2, 4, 6.
2, 4, 6. Okay, so if your first one, x is the first one, let's write it this way. I think it helps. Let's say this was the first one and I called it x. How did I get from 2 to 4?
Added 2.
We added 2. How did I get from 4 to 6? I added 2 more, right? So this would be consecutive even integers. So it would be, it says sum, so it would be add them up. So add the first plus the second plus the third equals to 72. So the first one we're going to call x. The second one was x plus 2. The third one was x plus 4. These are all equal to 72. So it looks like here's my answer for this one. Now, while we're here, I want to also talk about odd integers, because it could have been just as easily consecutive odd integers. And this is where it throws people off. They understand this to be the even ones. So can somebody give me an example of 3 consecutive odd integers?
3, 6, 9. Oh, sorry, 3, 5, 9.
3, 5. What would come next?
7.
7. Okay, so if the first one is 3, and the next one's 5, and the next one's 7, how do we get from 3 to 5? What do we do? Still adding 2, aren't we? And if we want to get to 7, we're still adding 2 more. So this part, whether they're odd or even, is exactly the same. The number that you set it to will drive it and make sure that it's an odd number or an even number, depending on what the problem asks for. So that does throw students sometimes. This part looking the same, they're like, no, 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 those are even numbers. I can't do that. But if you take an odd number and you add 2, you get to the next odd number. So trying, if you see odd or even, make sure that you put those pieces into play. So any questions on this one? It does help, I think, if you give yourself a concrete example and ask, how did I get from this number to this number? What did I do to keep going? You just keep adding 2 to get to the next odd number or to the next even number. Everybody okay? All right. So now this one is a lot like the other problem that we did. Let me actually get my calculator out just to make sure. It's still trying to combine like things, and we still have a parenthesis that we need to get rid of first. So let's go ahead and distribute. Now this time it's a negative. Bring the first term down. Now I have a negative times a positive. So I got to be careful with my signs. What do I get when I take a negative times a positive?
Negative.
Thank you. So this gives me a negative 0.84. Take a negative times this positive, it's going to give us another negative. So 0.4 times 3, 1.2 with an X. And then I've got a negative 0.21 over here. So I'm looking to add up like terms. I see this one has an X and this one has an X. So if you want to even rewrite them first and put them next to each other, so you can see it's a positive 0.5 minus 1.2. So I get a negative 0.7x, bring down this negative 0.84, bring down the other side. All right, so I am trying to solve for x. What would you guys suggest I do next?
Add 0.84.
Good. So it will cancel over here. And that will give me a positive number since this is larger. Looks like 60.63. Okay, almost done. What's next? What's our last step?
Divide by 0.7.
A negative 0.7 though, yeah. Let's bring that negative over because I want a nice positive x. So that will cancel the negative 0.7, leave me with just an x over here. And what do we have at this point? 0.63 divided by negative 0.7, and I get a negative 0.9. And so here is my final answer. So get rid of your parentheses, distribute, add up any like terms, and then figure out where your x's are. In this one, there was only one x term once we got done combining like terms. So we know everybody had to go to the other side. Watch your signs. They like to throw in negatives just to see if you guys are paying attention. Any questions on this problem? Be sure to use your calculators. If you have any doubt in your mind when you're adding or subtracting these, use your calculator to verify. If you're good with mental math, great. But because it's a test, I still would pull my calculator out and check it just to make sure I didn't miss something because I have test anxiety. So sometimes I look at stuff and I have to double check myself. So, okay. If there's no questions on this one, we'll go ahead and go to the next slide. All right, so with this one, we're no longer just graphing nice, beautiful straight lines, but we're graphing inequalities. So as you do these, there's a kind of a process you want to do. Your first step, you want to graph the line. So because it's already kind of in that y equals mx plus b, I like to take advantage of using the slope and the intercept. Once I get my line, then I have to decide, is it dotted or solid? And then I have to do my shading. So you can either use a guess or you can use a test point. So let's kind of work through this one and see what it looks like. All right, so we need to see what our line looks like. I see an intercept of 1. So I'm going to go through each one of these and put an intercept of 1. Okay, so far nobody failed. I have a slope of 2, which if I change that into a fraction, because it's rise over run, I'm going to take this original point that I drew and I go over 1, up 2. So over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. So everybody looks pretty good so far. So that's step 1. I kind of have my 2 dots. Step 2, I have to decide if I'm going to connect these with a dotted or solid line. So we're going to go back up to the original problem. If there's an equal bar, what does that tell us our line needs to be?
Solid.
Very good. So we are going to eliminate the dotted lines on this one. So right now it looks like these two are in contention. So if I connect the dots with a nice solid line, so that's step 2. Step 3, shading. So we want our y values to be less than the line. So if you had to look at these two and just make a guess, let's label these A, B, C, and D. Which one shaded less than the line? What do you guys think? If you just had to guess.
Would it be D?
Well, we eliminated D. So
Oh,
don't
okay.
look at D and don't look at A. We only have B and C because those are the ones that went through the right points for us.
B?
So B, how many of you guys think B? Anybody like C? Okay, well, let's figure out. Okay, because you're on a test and you're like, I'm not sure. So this is when a test point really comes in handy. So you can pick any point as long as it's not sitting right on a line. And it doesn't matter. So let's pick this point right here. It looks like that's 2, 0. And when we go to do our test, this will either be true or false. If it's true, we shade it. If it's false, we don't. All right, so which is this? So we're going to take this point and we're going to plug it back into the original equation. So 2, 0, and the equation was y is less than or equal to 2x plus 1. Plug in the x and y values. So 0 less than or equal to 2 times 2 plus 1. So the y was 0, the x was 2. That gives me 2 is less than or equal to 4 plus 1. So is 0 less than or equal to 5? Is that true or false?
It's true.
It's true. So the point that we chose is in the good area. So we definitely want to go ahead and shade to include that point because it gave us a true value when we plugged it in. These inequalities have hundreds and hundreds of points that work. So you just have to find one. Either if this had been false, I would not have shaded it. I would have shaded to the other side of the line. I usually can remember if it's less than, it's lower than my line. If it's greater than, it's above my line. But it never hurts to do a test point and check and make sure. So 3 steps to do these. Get your slope and your intercept, use it to get your 2 points, decide if it's dotted or solid based on whether there's an equal bar underneath your inequality or not, and then do a test point so you can see which way to shade. And if your teacher's given you a pencil paper test, this is exactly what they will be looking for to distribute the points. And if you're on Lumen, this is more what it will look like. You'll get a bunch of choices, and as soon as I look at this and I say, oh, you're solid, I can go ahead and eliminate the ones that have dotted lines, and I've already increased my chance of getting the question right. So All right, there was a lot of steps to this, 3 steps, and each one is just as important as the other. So any questions? Anything you don't understand? Okay. I'm taking you at your word. All right, so solve the compound inequality. All right, so when I tell my students, because they look at this and they're like, oh my gosh, there is so much going on. And there's a trick visually. I'm going to do something and I think it will help. And you can do this with your hand, you can do it with a piece of paper. What if you were to cover up the first part? The first part with the first inequality, since there are 2 of them. Would you guys know what to do with this? Would you know what to do to start solving for X?
Add 4.
Yeah, so if we look at this without the box, we know we need to add 4, right? The thing is, there are 3 regions here. Before the inequality, in the middle, and after the inequality. So to keep everything balanced like a choo-choo train, it's kind of how I think of these. If I'm adding 4 to the middle and I'm adding it to the caboose, I'm going to add it to the front engine also. That way everything is balanced and that 4 clears off. -16 plus 4 is a -12. Let's bring down everything that's left. Okay, I'm still trying to get the X by itself. So if you were to cover this up, or maybe by now you can kind of ignore it for a second, what do we need to do to get the X by itself? Any ideas?
Divide by 3.
Perfect. So if I divide the middle by 3, I have to divide the engine and the caboose by 3 also, right? So that leaves me, that 3's cancel, and that leaves me with a 5. So now I look at this and I don't see this over here. It looks like they want this in interval notation. So starts with a -4, ends with a 5. Okay, this does not have an equal bar beneath it. So what does it get? A parenthesis or a bracket?
Parenthesis.
Very good. This one doesn't have an equal bar, so it also gets a parenthesis. So here we go. So if I covered that first part up with that box, did that help you guys kind of see where to start? You may not
Yes.
need it. It helps me kind of like, oh, wait, there's a lot going on. And if I can simplify it for my eyes at all, my eyes will say, oh, well, you're just solving for X. Let's add the 4. Okay, well, at least then I know where to start and I can stop freaking out and move forward. Okay, any questions on this one? You will find those of us that have test anxiety that are math people, we've had to find a bunch of tricks and things to help ourselves, survive along the way. So that's one nice thing when you come work with the tutors in the Learning Commons, or even your teachers, we've all got tricks that we've used so we can be more successful. Okay. This one, there's absolutely no work to it, but you do need to understand what's going on. So you guys have dealt with systems of equations that had 2 equations with X's and Y's in them typically. When you look at this would be like one line, and this would have been the second line that you were dealing with and were given and to solve. How many times do they cross each other?
One.
So how many solutions are to this system?
1.
1. If they didn't cross each other at all, let's say they were parallel lines, then it would have been the empty set. If this were 2 lines that somehow one of them got multiplied by another and they ended up laying right on top of each other, that's when there's infinitely many points, because they are the same line. They're touching everywhere. They can't keep their hands off of each other. So here they touch 1 time, so there's 1 solution. Here they never touch, so there's no solutions, empty set. And here they touch everywhere. They agree everywhere. So there's infinitely many points. So that way, no matter what they give you, the first one is their favorite, but no matter what they give you, these are your 3 types of solutions that could come up. Any questions on this? I like it that there's no work, but you do have to think about what you're seeing. All right, let's go to the next one then. Okay, this one, I know you guys love fractions. You're like, give me some more fractions, yay. All right, said no one ever, right? So anytime I'm adding and subtracting fractions, what do I need?
Common denominator.
Thank you. I need a common denominator. All right, so I'm looking at 4 and 3. What number do I know that they both go into?
12.
12. Okay, so this is the trick on this one. Everybody, if I multiply both sides of something, it doesn't change it, right? As long as I'm consistent. If the left gets multiplied by 12, the right has to get multiplied by 12. It's kind of like, I'm the oldest of 11. So if my mom brought candy home for one of us, she had to bring candy home for everybody or she was in trouble. So I'm going to take each of these pieces and I'm going to multiply them by 12. And then I'm going to look to see, this is my favorite part, the canceling. Okay, 4 goes into itself one time and into 12.
3.
Times, right? How many times does 3 go into 12?
4.
How many times does 4 go into 12?
3.
3. So we no longer have any fractions. We have a 3 out in front of the x plus 3 greater than, I don't have to flip it because I didn't multiply by a negative 12. 4 in front here and a 3 in front here. So before we go any further, take a look at that and see if there's any questions. Anything that disappeared that you don't know where it went or why we did this. Everybody feeling okay? Okay, now we can just go ahead and distribute. So let me get a different color. Let's go ahead and just distribute anytime there's a parenthesis. And let's see what we're left with. So 3x plus 9 greater than 4x minus 8 plus 3 times 1 is a 3. Nothing that I can combine on the left. So let's just bring that down. Over here, I can combine these two numbers. So 4x, a negative 8 plus 3 gives me a negative 5. And now inequalities are a little bit easier to understand. Typically, if we get our x's on the left side. So I'm going to bring all the x's to the left side and combine them. So that means I need to bring this 4x to the other side. The 9 doesn't have any x's, so I'm going to bring him to the other side. And then let's do a little bit of cleanup. So the 9 canceled here, 4x canceled here. So I had 3x minus 4x is a negative x greater than negative 5 minus 9 was a negative 14. And now I'm still trying to get the x by itself. So I have to divide by a negative 1. And at this point, a little bell should have gone off on your head, right? We divided by a negative number. What does that do to our inequality?
Flips it the other way.
You have to flip it.
Yeah, very good. So negative x divided by negative 1 leaves me with a positive x. Negative 14 divided by negative 1 leaves me with a positive 14. Now here, they left it just like that. But if they had asked for this in interval notation, let's look at that real quick. So 14 is our number, negative infinity, positive infinity. The n is pointing to the left. The inequality is pointing to the left, so I shade to the left. So if they had asked for this in interval notation, I would have gone from negative infinity up to 14. We know infinities always get parentheses. And there's no equal bar. So the 14 would have also gotten a parenthesis. This one had a lot of steps, common denominator and parentheses, and then cleaning things up, and then that tricky little flipping to get our final answer. So take a second, let me know if you have any questions.
Sorry, I got confused. So why did we have to subtract 9 from both sides and
Because-
negative 4x?
Because we're trying to move this 9 across the inequality. Right now it's being added. So the opposite thing would be to subtract it. And if I do subtract 9 on one side, I have to subtract 9 on the other. This 4x over here is a positive. So I need to subtract it to clear it out from over here so it cancels. And then, of course, if I do it to one side, I have to do it to the other. Now, you don't have to do this in one step. If,
Oh, okay, maybe that's why.
okay. Sometimes I do it in one step, sometimes I do it in two, depending on what I see. So at this point, we had x plus 9 greater than 4x minus 5. Oh, this was a 3x, I erased it. So you could go ahead and just bring the 4x over first, doing the opposite sign. So this one cancels, leaves you with negative x plus 9 is greater than negative 5. I want to try to isolate the x term. So that means that 9 has to go over to the other side. Negative x greater than negative 14. And then I can divide by the negative 1. And I get x less than 14. Does that help?
Oh, yes, yes.
Okay, good. See, that's why I told you guys ask questions if something doesn't make sense, because I can do this several different ways. And that's the nice part about math. There's not just one way to do all the way through. Okay, any other questions? Okay, cool. This is our halfway point then, number 10, slide number 10. All right, so suggestions on this one? Where would I start?
Probably first combine like terms.
Not quite, that's my
Distribute. I'm
second.
gonna say distribute.
Very good. So let's distribute and get rid of these parentheses.
Yeah.
So 4 times x, 4 times a negative 1. And distributing this 3 times x gives me 3x, 3 times a negative 2. Bring down that 2x. Now I see a couple things on this side that I could combine. So do a little bit of cleanup. I always tell everybody, clean up your own yard before you kind of go look at your neighbor's yard. So 3x plus 2x is a 5x. And now I can say, okay, I really do want to get my x's on the left. So what would you guys think we should do next?
Subtract 5x.
Good. All right, cancels this guy. 4x minus 5x leaves me with a negative x. Bring down the negative 4 and the negative 6. What would be a good next step?
Add 4 to both sides.
Good. So negative x is greater than negative 2. And then I can't leave it as a negative x, right? So let's divide. Did that little warning bell go off in your head?
Flip the yeah, flip it.
2 divided by a negative divided by negative leaves me with the positive. So here, they didn't want the answer as an inequality. They did want it as an interval notation. So let's put this 2, negative infinity, positive infinity, put the 2 on there. X is less than 2. Again, this time they shaded it this way. All right, so on the left, I see a negative infinity. On the right, I see a 2. Infinities always get parentheses. So is this 2 going to get a parenthesis or a bracket?
Parentheses.
Okay, very good. And you see they switched it all up because sometimes students forget that you want smallest to largest. So you don't want to lead off with your original value. You want to lead off with the smallest one. And that's why when I draw it, I can see the negative infinity is to the left. So I'm starting with that and it stops at the 2. All right, any other questions? I want you to make sure you get to the point where you hear that little warning bell say, oh, I divided by negative, or I multiplied by negative, I get a flip. Kind of like Tinkerbell. Wait a minute. Okay, any questions before we clear this and go on? Okay. So now we're going to do some inequalities, but we're going to do some of the compound ones. And the ands and the ors start off exactly the same. It's only when you choose your answer that they're different. So you're going to have two separate small equations, inequalities to deal with, which aren't too bad usually. They're not too crazy. So you do them separately. And it doesn't even matter which one you do first. So I'm going to do this one. So all I have to do here is subtract that 7. X is less than 8. So that one's done. Let's work on this one. Let's bring the 4 over. So 2x is greater than or equal to 6. Getting the x by itself. X is greater than or equal to 3. So this is where the number line is definitely your friend. Okay, 3 is smaller than 8. So I'm going to put 3 and I'm going to put 8. Okay, so let me get a different color here. All right, so this says x is greater than or equal to 3. Greater goes which way? Left or right?
Right?
At the end of greater is an R, so you're going to go to the right. And when I look at this, there's an equal bar this time, so I'm going to close that circle in. Now I'm going to get another color and I'm going to graph this one. 8, so I want x to be less than goes to the left, going to the left. And this one does not have an equal bar, so this one's open. So now let's go back and see what the actual question asked. This one was an and. So an and, if you have an and, they have to overlap. Kind of think of it as they have to agree. So where do these two guys agree? They don't agree over here where it's only orange, and they don't agree over here where it's only purple. And that's why I like to use different colors. They agree from here to here. They overlap from here to here, right? Well, this one had a dark circle and this was nice and continuous. So this one can get a bracket. This one though was limited by the open circle, kind of like that game show, You Are the Weakest Link. This purple line was nice and straight and continuous, so it acted like a closed circle, but the orange had an open circle, so it gets a parentheses. And somehow I wrote the wrong answer on here. So this is the right answer. If it's an and. So do each one of them separately, graph them on the number line, see which way they're shading, which way they're going, and then see where they overlap if it's an and. We're going to do one more like this, but we're going to do an or. So you guys can see how you think differently through each one. So again, they're going to start off giving you two unique problems to do individually, independently of each other. So we got to get rid of our parentheses, right? Go ahead and distribute. Some people have trouble with this second one, so we'll do that one second. So 2 times 5x is a 10x. 2 times a -7 is a -14, greater than 4. Trying to get the x by itself, so let's add that 14. Cancels over here. So 10x is greater than 18. Divide by the 10. And x is greater than 18 divided by 10. How do they want these? They want decimals. Okay, so if you put this in your calculator, you're going to get a 1.8. Let's go ahead and do the second equation. This negative in front acts like there's a -1 that we have to distribute. So -1 times x gives me a -x. -1 times -6 makes it positive. Trying to get the x by itself, so I'm going to bring that 6 over, cancel it. So -x greater than -14. Divide by the -1. Tinkerbell, the little bell's jingling. So I got to flip it. Negative divided by negative makes it positive. Still going to do a number line. 1.8 is smaller than 14. So let's put it down here, put the 14 up here. Okay, the first one says graph x is greater than 1.8. There's no equal bar, so I'm going to do an open circle. Greater goes which direction? Right or left?
Right.
Okay. Okay, let's get a different color. X is less than 14. There's still no equal bar, so we got an open circle. And less than goes which way?
Left.
Very good. Okay, now let's go back and see if this is an and or an or. It's an or. Oh, okay, okay. So this is, if either one of us likes it, we bring it home. It's kind of like if you move in with somebody, you bring all your dishes, they bring all their dishes, and you just throw them all in the same apartment. So if anything got shaded, we're going to include it in our final answer. So it looks to me like if I start out here, the orange line goes all the way out to negative infinity. It overlaps with the pink, and then the pink takes off and keeps going. So it looks like the whole number line got shaded. So the or doesn't have to overlap. It's anywhere that either one, any that either contributes. Kind of like if you're making soup, you throw your stuff in, I throw my stuff in, and we get soup at the end. So the problems are the same until you make that final decision. If I were doing this one as an and, what would you guys think the answer would be? Remember, an and is where they overlap.
814.
I'm sorry?
Would it be 8, 14?
Or 1.8, comma 4.
Oh, sorry, yeah, yeah.
And both of them have open circles, right? So I'm going to put a parenthesis on both of them. So no matter how you work on the same, but then be sure you go back and verify, is this an and or is it an or? All
I
right.
have a question. Can you go over one more time how you switched it from because the way I solved it, I got a fraction.
Which part? On the first part where we had 18 over 10?
Yes, and I simplified and got 9 over 5.
Okay, put 9 over 5 and 9 over 5 divided by 2. But what did you get when you put 9 over 5 in your calculator?
1 4/5.
Oh, yours must be set in fractions.
Okay, how do I change it?
Do you have a F to D button?
F to D.
What calculator are you using?
A Texas Instrument 30X, the regular scientific calculator.
Okay, yeah, I think you're looking for an F to D button or a D to F button. We'll take it from fractions to decimals.
Oh, yes, I see the F to D button.
Push that and then push enter and see what it does to it.
Okay. Oh, yep, it switched it around for me.
There you go. Because sometimes you're fortunate that you have a calculator that does fractions like that. That's a good thing. But check the answers out. And if there's no fractions over there, go ahead and convert your fraction to a decimal.
Got it. Thank you so much.
No problem. Any other questions on this one? All right, go to the next one then. Slide 13. Okay, this one is another fraction. So I want to come back to this. I do want to make sure we hit everything first. What's on 14? Okay, let's look at another application problem, another word problem. Okay, so this one is a triangle. Just a good old basic triangle, nothing fancy, 3 corners. It says the measure of the interior angles could be represented as x, 2x, and x plus 20. Now there's something you have to know about triangles. What is the total of all the interior angles?
180
Perfect. So
degrees.
all we have to do is add them up. So I have x plus 2x plus x plus 20. So this is one angle, two angles, three angles. And labeling like this will help you when you get the answer, because once you get x, you're not done. It said find the measures of all three. So once I get x, I can come back in and plug them in and find all three angles. All right, so I'm going to add up like terms. Looks like I have a bunch of x's. So 4x plus 20. That cleaned it up a lot. It was 180. Let's go ahead and bring the 20 over. 4x equals 160. Divide by 4. So I have x equals 40. So that means I know this one. That's all I know so far. I have to go calculate the others. So what is this angle here? If the measure was x plus 20, what's the actual degrees of that angle?
60.
60,
Perfect. How about the 2x one? What do I put there?
80,
Okay, now, just in case we made a mistake, let's add these all back up. We should be getting 180, right? When we add these up, look at that. So I know I am absolutely right. I don't like to be wrong. I don't like to get red marks on tests when I take tests. So I do like to check. And this is really cool because you can just add up the three numbers. And if they don't total 180, you go back over here and see if you added something wrong. Questions on this one? Okay, cool. Look, now this one is dealing with the rectangle. So let's draw our rectangle and see what they're giving us. All right, the length is 5 more than the width. All right, so I have a width and I have a length. They didn't tell me who to be what. So they said find the value of W, which is the width. Okay. The length is 5 more than. What does more than mean? You guys told me this a little while ago. Add 5, right? 5 more than that. Okay. So does anybody remember the formula for perimeter of a rectangle?
2L plus 2W.
Good. Now there's one trick on this one because it's not an equals. It's an inequality. They want the perimeter not to be equal to a number, but they want it to be less than 86. So you guys see how you go from the regular perimeter formula to convert it to an inequality. Now, length we said was W plus 5 plus 2W. And now everything is in terms of W, which is what they want to know. So we can solve this and we'll be done. So let's go ahead and distribute. So I get 2W plus 10 plus 2W less than 86. Add up these two like terms. We get 4W plus 10 less than 86. Go ahead and bring the 10 over. Cancels there. So we have 4W less than 76. And now we just, last step, get the W by itself. So W has to be less than 76 divided by 4 is 19 feet. So as long as we make the width less than 19 feet, they'll have enough fence and they can go ahead and put a fence around this perimeter. I don't know if it's for, I have chickens, so I would think, oh, that's from my chickens, or maybe it's from my puppies so they don't get out of the yard. So they must have 86 feet worth of fencing. So they've figured out as long as the width is less than 19 feet, they'll have enough and nobody will get out. So any questions? Matthew, did you have a question?
No, ma'am, I just pressed the wrong button, sorry.
Okay. That's the nice part about this. If you guys need to draw something on here or write something and let me know what you're not sure, you always can. Even when you come to tutoring, you have that ability. So, all right. Let's look at the next one. So the next 1, 2, 3, The next three, okay, and then there's a graphing one. All right. So the next three are all systems of equations. And those answers that we talked about a while ago, whether infinite solutions, no solutions, or one solution, that's going to be your only choices as you go through this. So you guys talked about several methods. You did graphing, which is okay, but it's not very easy to do sometimes. You did substitution and you did elimination. So typically we don't use graphing a lot. We usually use substitution or elimination. So when I look at these problems, I'm going to be looking, because let me go back a second. If you want to use graphing, if the equations are both y equals this and y equals this, and it's already clean and easy to do, yeah, graphing is a good method, but that's not usually how they give them to us. So we're either going to use substitution or elimination. Substitution is a good choice if you can easily get one of the variables by itself and don't create fractions. Elimination works no matter what the numbers are, if they're positive, negative, fractions, whatever. So I'm going to give you guys a choice. How do you want to do this one? Because this one I could work either way. You guys pick.
The Y's.
Okay, do we want to use substitution or elimination?
Oh, elimination, because
Okay.
this is y equals or x equals.
Okay, so we're going to eliminate. Okay, bye, Canna. I'm going to, because I look at this and I see one y is positive and one's negative, you're exactly right. I'm going to focus on the y's. So if this y is a positive 5, I need this one to be a negative 5. So what do I have to multiply this equation by to make that happen?
5.
And if I do it to one side, have to do it to the other, right? So the
Right.
first one we didn't change, so let's bring it down. Be careful you don't lose that negative. Distribute the 5, 15x minus 5y equals 55. And now we're going to combine these. Because we chose the right thing to multiply by, our y's cancel out. We can add up like terms, so 17, whoops, back. 17x equals 51. And then we divide by 17. So we get x equals, what does that give us?
3.
3. So look at that. We have our x value. So this must be like the graph I showed you guys earlier where the two lines cross and they have one answer because we already got one x. So now we need a y. Does it matter which one of these equations I go back to find that y value? No, because it's the same graph, right? So let's go to the first one. So 2x plus 5y equals -4. Plug in the x value that we found, and then we can solve it for y. So we get 6 plus 5y equals -4. Bring the 6 over. 5y equals -10. Ran out of room. So divide both sides by 5. And I get y equals -2. Now, because this is a test and worth lots of points, I'm going to go to my second equation and I'm going to plug both of these in just to check. So 3 times the x value minus the y value is supposed to equal 11. So this is my check. So 9, I get a negative times a negative. That gives me a positive. 11 equals 11, right?
Yep.
Yay, so we know we're right. So on all of these, this is going to be the same process that you're going to do. Kind of see, we're kind of running out of time. If you guys can stay, oh, we had till 4:30. Okay, never mind. Okay, next one, same idea. Elimination or substitution?
Substitution.
Exactly, because the y is already by itself. So I can take what y is equal to and I could plop it in where I see, I can take where x is equal to, plop it in at Michael, did you need something? Or Matthew, I'm sorry.
No, ma'am, sorry.
Okay, okay. Just wanted to check in case you wanted to write something and ask us about it. So we took, oops, I turned the wrong. Okay, go back to the right problem. All right, so we took what x was equal to, and we plopped it in for this x value. That's all we've done so far. And now we can go ahead and distribute so we can get rid of our parentheses. Add up like terms. And go ahead and try to solve for y. So let's minus the 4. So 5y equals 5. Well, that worked out really pretty. So y is 1. So again, if y is 1, I need an x to go with it, right? So I can go to either equation. I'm probably going to go to this one since it's the simplest one. So x is equal to y plus 2. We think y is 1. So 1 plus 2. So x would be 3. And if I want to check it, I could plug both of those back into equation number 1, and I could verify it for myself. All right. Let's look at the last one that's on here like this. Let's do this one with elimination again. So I'm thinking I'm going to, I guess it doesn't matter which I eliminate because neither one has a positive negative balance kind of thing going. So let's get rid of the x's this time. So when I look at this, I see 6 and 3. And I think, well, what would be a good common denominator for 6 and 3? What could I use if my numbers are 6 and 3?
6.
Yeah. So this first one's already exactly where I want it. I don't have to change him at all. He's got a positive 6x though. So that means I want the second one to be a negative 6x. So when I combine them, they will cancel. So to get this to be a negative 6x, I need to multiply both sides by a negative 2. And I like to rewrite it so I can visually see kind of what I'm doing. So I get negative 6x minus 2y equals negative 6. All right, so let's bring down what we had to begin with. 6x plus 2y equals 12. What we had here was a negative 6x minus 2y equals negative 6. Now, draw my line and combine. Okay, these guys cancel, leaves me with the 0. These guys cancel, leaves me with the 0. 12 minus 6 is 6. Okay, is this true ever?
No.
No. So this one has no solution, or it's an empty set. This is one where they're probably parallel to each other and they never touch. So that's what it looks like if you were to draw them, try to graph them. They would never cross each other. They don't ever agree with each other. So that's one of those. Now, what would the answer have been if I'd finished this up and I had gotten 6 equals 6? Then what would I have said the answer was?
Infinitely many.
Yeah. So all real numbers or negative infinity to positive infinity, whatever choices you're given. If it's a pencil paper test, just write all real numbers or always true, something like that. So either using the elimination addition method or substitution, your choice. Nobody's going to tell you how you have to do those. And you got to decide what's the easiest for you. All right. This one is pretty much always on the test. So let's make sure we get this one in. It is a system of equations, but to get the full points, you have to actually come up with the system. So there's 2 sentences here. So here's sentence number 1. Here's sentence number 2. We're going to use those to create 2 equations. The sum of 2 numbers is 20. They're telling us let one number be x and let it be y. You guys told me, what did sum mean to do with the 2 numbers?
Add.
What is it?
Add.
Add, thank you. So we're going to take x plus y, and what are we going to set it equal to?
20.
Okay, that's the first equation. The second one says difference. What does difference tell us to do?
Minus.
Okay, so we have x minus y equals what?
8.
Okay, that's A. That's the system of equations that they're going to be looking for. If you just give them the answers on this one, you're not going to get full credit. So be sure you write the equations down, and now we're going to solve them. So looking at this, I see if I just add these guys straight up, those y's will cancel and I'll be able to pop my x's right out. So adding these guys together, I get 2x, the y's cancel, equals 28. Go ahead and divide by 2. I get x equals 14. So now I have, it said find the two numbers. So I have to find the x and the y. Does it matter which one of these I plug it back into to find y?
No.
No, most of us don't like subtraction as much, so I'm going to go for the plus. So 14 plus y equals 20. Bring the 14 over. Y is 6. If I plug that back in my last one to check it, is 14 minus 6 equal to 8? Yep.
Yeah.
Ta-da! I like checking because it makes me feel good. I'm like, ooh, got it right. Okay, I think that's really, because I think this is a repeat here. Yeah, it's a repeat of the graphing. Okay, so is there anything in particular that you guys still have questions on, or any of these problems you want to look back over?
Can you go back to number 10?
Yep. What is it about this one?
Oh, wait, no, not that one. It was the one you skipped. It was like a word problem.
I skipped a word problem?
14.
14.
Yes.
This one with the fractions?
Oh, well, yeah, we can do that one, but I think I kind of got the fraction. But I
Okay.
wouldn't mind trying it though to make sure I'm right.
Okay. All right. So I see fractions with addition. So you guys told me we need a common denominator. So let's bring our numbers over, look at them. What would be a good common denominator for 6, 3, and 4?
12.
Yep. So we are going to multiply everybody by 12. I do usually like to rewrite this so I have room. I don't want to be crowded because then I make mistakes and lose things. Oops, equals 12 times 2/3 plus 12 times x minus 5 over 4. Okay, let's do our canceling. 6 goes into 12. How many times?
Um,
Okay. I know it's not supposed to be a hard question. Just 3 goes into 12.
4.
4 goes into 12.
3.
All right, let's see what we have left then. We have a 2 and an x plus 3 equals a 4 and a 2 plus a 3 and an x minus 5. So no more fractions, but we do have a bunch of parentheses. So let's go ahead and distribute and see what we have left. So 2x plus 6 equals 8 plus 3x minus 15. I can add some things on the right-hand side that are like terms, 8 minus 15. So 3x minus 7. And I'm trying to solve for x. So we usually try to get our x's to the left side. Doesn't matter because it's not an inequality. So let's bring our x's to the right-hand side this time. So it means, well, let's bring this 2x over. Cancels over here. 6 is equal to x minus 7. And whoops, add 7 to both sides. And it cancels. I get 13 equals x.
Yes. Okay.
Okay. See, by multiplying it like this, and you can visually see, some people try to do it all one side and where does it cancel? Where does it cancel? I'm so visual. I need to see how this cancels. I need to see how this cancels and what's left. So I've always had really good luck with doing all those little individual pieces so I don't lose somebody. Okay, is there another one you guys want to look at again?
Question number 16.
Let's see which slide, 16, okay. Okay. What part of this one was not quite as clear, you think?
Um, I don't know.
Just from the beginning?
Yeah.
Okay. All right, so we have a length and a width, right? Because it's a rectangle. And they told us the length is 5 feet more than the width. So I don't know anything about the width. They said call the width W, okay? But the length is 5 more than that. So does that part make sense?
Yes.
Okay. And you guys told me the perimeter formula was 2L plus 2W, right?
Yeah.
But we don't have something that this is equal to. We are taking this from an equals to a less than 86. So are we okay to there?
Yes.
Okay. Now, I see two variables, but up here I was able to write the length in terms of the width. So I'm going to take that length and I'm going to replace it with that W plus 5. So now everything's in terms of W, and that's what I'm solving for. So, and then I can go ahead and distribute. And then go ahead and combine like terms and solve. So we end up with what? 4W plus 10 less than 86. Go ahead and subtract our 10. So 4W less than 76. Divide by your 4. So W has to be less than, what was that, 19? And then everything's in terms of feet. So this, I think right here is probably the tricky step for students. They're like, I know the perimeter formula. I've learned that for a long time, but you're wanting me to get rid of the equal part and set it strictly less than 86. And then go ahead and solve it like the other equations. Did that help?
Yes. Thank you.
You're welcome. Okay. We got a few more minutes. Is there any other requests or types of problems?
Yes, ma'am. I'm sorry, I was a little late. I came in on question number 5, but I had a question like on the you know how it gives you like X is less than 9, and then it tells you to put it in like the right here. Boom, yeah, that's perfect. Like that type of problem. I was kind of noticing that like normally if it's less than like what's the easiest way to solve this? Okay, the number line.
Number line. There's no equal bar, right? So I kind of want to make sure there's an open circle. This
Okay.
thing is pointing to the left, so I'm going to shade to the left. And then I'm going to give it the interval. The intervals always go from left to right.
Right. So it's just how you see it. Okay. So that's what it is. If I put it on a number line, it'll be much easier to determine
Yeah.
because it's looking at it. It's like, okay, now do I put the 3 over here on the left or the right? Okay. So now I see.
Yeah.
Okay. That makes sense. So I just use a number line for that.
I like to, I mean, even when I'm helping calculus students and something, if we can get a picture, it always makes more sense to our brain. Okay. Anything else? Okay, just so you guys know, Learning Commons is open till 7:30 tonight, and we open back up at 7:30 in the morning. So if you have any other questions, just let us know. We're here to help.
Do we get a copy of this review?